Hi, g'day, and welcome to our second bite-sized TOI. I'm Tim, and today I'm going to be talking about some new database partitioning features in JADE 2022. First up, multi-class partition files. It used to be that you could only put one class in each partition file. In JADE 2022, we've lifted this limit. We've made some enhancements in order to make that possible. So several features have been extended. For example, the make partition command of jdbadmin has a new form, and we've also added a new process for converting your old single class partition file into the new sort. We've also got some new JADE methods for you. So first lot of these are, we have some previously unpublished methods that we've gone ahead and published. That's in JadeDB file partition, we've got the purge instances method, and for bonus points, we've also made it way faster. And we've also got the remove method. Now, we also have some brand new methods for you as well. These are on DB file class, and they are get max partition ID and set max partition ID. We've also added some new .NET methods. So three of these are, first of all, on database file partition, we've added the purge instances method, and then on database file class, we've added two new methods, get and set object partition. If you're keen to know more about any of these methods, join Hugh McColl and I for a whiteboard session. We're going to be talking about these and more with respect to database partitioning in depth. Welcome to our second TOI whiteboard session. My name's Tim Aitchison, and I'm here today with Hugh McColl, and today we're going to be talking about database partitioning. Now, Hugh, I know a little bit about database partitioning. As I understand it, the basic idea is that we've got one logical JADE map file corresponding to multiple of those .dat files in the file system. But can you tell me a little bit about why is that a good idea? How does that help us?
Yeah, cool, Tim. Yeah, that's a good question. So let's see if we can draw something on the whiteboard. So as you say, by default, we have a concept of a map file. Let's say map file, and we usually have a DAT extension. And all of our objects are stored there, but there's kinds of data that tend to accumulate, and you end up with very large map files, so they can be orders of multiple gigabytes, terabytes even. So what's bad about that? Usually it leads to management overheads. It means that things like backing it up and doing reorgs or compacts are slow. So what we want to do is what I call a divide and conquer. So let's look at splitting it up into smaller parts and seeing what we can do with that. So I'll try and draw something up on the board here. So we'll draw something, we'll chop. We're going to go from a monolithic file to something smaller and chop it into pieces that we call partitions. And then so the basic idea is to take a single monolithic file and break it down into chunks, and we call these partitions. So
these partitions, are these separate files on the file system?
Yes, correct, Tim. So each of one of these will map to a physical file on the file system. And that's where we start to be able to do more things. So by having multiple small files, we can do things in parallel with them. So when you're backing up, we can have multiple workers backing up different sets of files. We can have multiple reorg workers reorging or compacting. So that's the first level of advantage. And you might wonder why I draw a dotted line. So the next thing you can do is start treating those differently. And there's several things you can do. So I'll draw going back in time, let's say put a dot. And I'm going to label these active partitions. So these are the ones that you are actively working on. They're highly volatile. You're reading and writing things often, but data that accumulates tends to age. So we'll look at older partitions. So this is a point in time, and this is now, so current. And the next thing, we've got options like we can freeze them. And why would you want to do that? what that does is make them read-only. And it means that you can then say, if the application accesses it, it'll get an error because we're now saying we're going to archive these, but we still want to read them. And you can do things like relocate them to different storage solutions.
So you might have like the active one on a really fast
Yes,
disk,
exactly.
and then these ones on some cheap disk.
Yeah, so you might have those on SSDs, and this is on old clunky spinning disk, but you can still access it. You're not accessing it frequently, so there's a cost saving. Cool. Then you can go further. So we've got active partitions, we've got frozen relocated partitions, and the next thing you can do is mark them offline. What that means is they're marked as not available now to the system, which means you can remove them completely and obviously back them up. But on the occasion, say once in a blue moon, you do need the data, we still allow you to bring those back and access them. If the application attempts to access an offline partition, it gets an exception, and that can be translated to a signal to an admin person to bring the offline partition online again.
So that would be something like maybe historical data where
Yes.
you're not actually doing anything with it, but you might need it sometime in the future. You don't know, you don't want to get rid of it yet.
Yes, correct.
Cool.
But there might be legislative reasons that you can't completely remove it, so you have to have it somewhere backed up, but not completely accessible by the live system. And furthermore, if you've got SDS, you can have a different set of partitions offline on SDS. So primary could have everything online. The SDS secondaries could have a selection offline because the secondary doesn't need them. That's a choice that we give you.
Cool, that seems pretty useful. Now, I understand we've made a whole bunch of new changes in J 2022 to this database partitioning. And I also hear there was a bit of an interesting story about the onus or the decision to make some changes in this area. Can you tell me a little bit more about that?
Yes, okay. Yeah, that's a good lead into how this came about. So this basic partitioning that we're talking about goes way back. We did it in the 6.3 release. And there are several users using it, but it had some constraints. So what led us to remove the constraints? Where that came about, we were sitting on a customer sort of challenge well, basically it was a customer that was going through all of their current challenges. So there were lots of them. We had quite a big committee look there with people from Jade looking at, we had ops guys, product managers, POs, etc., listening to the series of challenges from the customer. And one that stood out as one of their biggest ones was around data management. And it was things like the time it took to reorg and do things like that. But not only that, how long it took to delete data. And they had specific use cases where they wanted to bulk delete a large amount of data. And later on, so the first question I had to them was, have you considered using data partitioning?
Oh, interesting. So they didn't actually request the changes so much. We were like, hey, I see you've got this problem here. I think we might know what we can do.
Yes, correct. So that opened the conversation. So we said, yes, have you considered partitioning? And one of the developers said, yeah, we have. But what we found now that it's very hard to apply. We've got lots of databases out there. And to go to partitioning, we'd have to make major changes in order to enable it, and they're a bit restrictive. So we'd really like to use it, but you need to make it easier for us to use. So we took that on board, and that was the start of an ongoing iterative discovery session. That involved primarily the developers who raised that and operations. So the operations guys were actually the ones that were feeling the pain and the cost, because there was a big cost associated with this delete and scenario. And actually, as a result of those follow-up conversations, we learned about one of their worst case scenarios where they had to basically delete a chunk of the data, pretty much. And I knew it was going to take a long time. It ended up taking something around 40 hours elapsed, and they couldn't do that. The impact of doing that, even on a weekend, was too great, so they split it across about 3 or 4 weekends. So they did bits incrementally. And the biggest pain for them was the amount of database journals it generated, because we were journaling every individual delete object. So they actually generated terabytes of journals. They were only deleting their database was only 1 terabyte. Multiple n terabytes of journals were created. And that's because we're earning quite a lot of data in order to be able to recover of each object. So that was a big operational challenge, and that's one of the things we wanted to address. So we wanted to make it easier. Right, so
that was one of the new features, wasn't it, that bulk delete?
Yes, but the main bit was actually removing the constraints of that were stopping them from using this.
Right, so they had like a real use for database partitioning, but they couldn't really apply it as it was.
Yeah, because to do it would mean a major restructure of the database. So that's the main thing we wanted to make easier. So that making it easier was the main thing we did in 2022.
Cool. So let's go in, if we may, into a few of the specific changes that we made along the way.
Yep.
So just to pick up on a few things that I noticed when going through the list of changes. One is it mentioned some IDE and compiler changes. Can you run me through a few of what those are?
Yep. So before I go to that detail, we probably want to cover the main change.
Yep.
So the constraint with using this goes back to 6.3. And what that was, when you want to partition a file like this in that manner, it had a constraint that could only contain instance of one class. And actually the reason we did it was to make it easier to not shoot yourself in the foot, because just think of it a scenario, you've got millions of instances of one class and maybe 2 or 3 of another. And if you don't think about that carefully, then if you reorg or change those two, you end up having to reorg everything. So we wanted to prevent people doing that. But on the other hand, trying to make it easier to not shoot you in the foot makes it harder to apply this to an existing model where you've got lots of files with multiple classes. So the main change we have now is a variant of a database file containing instances of multiple classes that can now be partitioned in that manner. So basically you can turn this thing on and start partitioning those. So back to your question, Tim, changes in the IDE were to enable you to set that up. There's an attribute on a map file called partitionable. And that says that I want to have the ability to partition this file. Why we have partitionable that just says, give me the ability to partition it. There's a second property called partitioned. The reason we want both is partitioned is something you do at runtime when you deploy it. This just says, I want the ability to do it. And we needed that to enforce the constraints.
Right.
The IDE and compiler knows that prior to 2022, it had to enforce this constraint. There are much fewer in 2022. That one's gone. There are a few others. So that's all that does. So the compiler and IDE had to manage that with the new rules.
Nice. So I guess the next thing to talk about is in the JDB admin, there's a partition there's a new form anyway, the partition method. Can you talk a bit through that one?
Yep, sure. So I might have to move a bit of that. I'll just rub a bit of this off. So I think what you're referring to is what we call a partition ID method. Did I spell that right? Partition ID. Prior to 2022, we had a partition index method, and that was designed to handle a specific use case. I'll see if I can quickly draw that up. It was to support what we call sliding window scenarios. So if I overlay it on here, we've got active partitions. In the sliding window scenario, the way that works is the latest partition is partition 0, and it's numbered backwards, 2, 3. And what you end up doing is having your active partitions that I call here are defined by a modulus. So if you want to maintain, say, a year of partitions, you set your modulus to 12. And let's say there's 12 of those and they're monthly. The way that works is when you switch over a month, you create a new one. So the 0 slots up, slides along. So your year goes along here. And the partition index method that we had is basically you say, if I want to go in latest, just set it to 0. If I want to go into the next one, 1, and so on. But it automatically, as you move the window, that's automatically slides, and that's how we call it the sliding window scenario.
So we don't have to manually move partitions to these older ones.
No.
We can just say, hey, we want this many to be
Correct.
active.
It automatically maintains this active partition window. So roll on 2022, for the use cases that we were dealing with this customer, we needed something else. Their two use cases were the ability, one was to rapidly bulk delete efficiently, something that's related to an organization unit or OU. The other one was data raging. Both of these are topics in their own right. I don't know if we'll have time to cover it, but data raging was another one. Partition ID, in contrast to index, is a way of saying and defining an absolute partition in this space that you want your data to go in. So that was key to being able to implement these scenarios. And we can go into that in another day. That's a topic in its own right. But
Nice, sounds good. Now, one next thing to cover, I guess. If I have... Oh, sorry.
I was going to probably, just before we move on, I'll give an example of a partition ID method.
Yeah, sure. Sounds good.
So, let's see. The main difference, so a partition index, we distinguish them by the signature. So a partition index method returns an integer. These methods have similar constraints to condition-safe methods. So they can only access state on the receiver object. And there's multiple reasons behind that. So partition index returns, let's just say returns index for now. The difference between that and a partition ID method is, as I say, that's a relative index. Partition ID method's a absolute partition. The difference is the signature becomes an integer 64. And what we do here is some way of identifying. I'll just give you an example of how we do this case. So what that would be is you'd assign an ID to each of your OU units. You'd return something like OU ID times, let's say, max months. The idea here is, as you can see, so what we're allocating is a slot for each OU. starting from 1, 2, 3, and they get a slot that's multiplied by how many months of data you want.
So that's quite clever. So that will mean that what goes in what .dat file can actually be based on some sort of business rules or logic behind it.
Correct. And so you can see max months, if you want 3 years, would be 36, 48, 60, and so on. So that that tells us how many in the system you want. The OUID allows you to reserve slots for that data. And the data ranging actually is built on that, whereas you chop that up further and you're going to pull in other properties that are temporal. So they'll usually be based on timestamps in the object.
So that would mean if I wanted to, say, delete one of my organization units, that's going to be super fast now because I know exactly where they are. I don't have to search through everything to find.
Yeah, so once you've applied that, we can use that to direct the objects based on just that property to a specific partition. There's one other thing we did to make this super easy, because for the customer in question, they didn't necessarily have this property on everything because they didn't need it. It's an object model. They can traverse the model to get things, so you didn't need to go via an OUID. So what we did is, to make it really easy, we now support that being a dynamic property.
Oh, nice.
So you can add a dynamic property without a reorg and start using
So I imagine some of these big systems, doing a full reorg just to put these things on.
Yeah, you don't need to do a reorg, you can add it.
Nice.
There's a question you might ask there, but I'm not going to ask it. Probably run out of time.
Let's focus on the best things. So I guess next thing to talk about is if I've got one of the old style
you mean one
single
of these?
Class. Yeah, so I've just got some class. Can I do a bit of a conversion and make it the new sort that can have multiple classes in?
Yep, so good question. And we knew people would want to do that. Not this customer, because none of theirs were partitioning, but we know there are customers with the single class partitions. In order to start making use of this capability, we need to convert it. So there's a process to do that. It's highly optimized, and you can run it online. So basically, it's a command line tool. You run it, JDBadmin, I should call it. So it's the DBadmin class. So there's an additional command line, run the convert process. As I say, you can run it online. So you can have transactions in process, convert in progress, convert your single class to multiple class format, and that enables you to make use of all this capability. But you don't have to do that because the 2022 DB engine supports both. So you can never do that or do it whenever you want.
What if I want to be extra tricky and mean? What if I've got a map file that isn't even partitioned at all, and I want to start using partition on it? Can I do this with an existing map file that isn't partitioned?
Partitioned? Correct. So if you were on prior to 2022, you could only do it if it only had a single class. But now you can come along and say pretty much any file, except that we don't allow you to do it on the default map file for a schema, but for pretty much any other ones, you can now set that attribute and run the command to partition it.
So you don't have to create new map files. You can just take your existing ones and just switch them over. Yeah. So that's pretty awesome. Yeah.
That's what they wanted. That's what they got.
Nice. And it's useful for lots of people, I'm imagining. Now, so there's been heaps of cool new improvements, I guess, to this area. Can you gaze into the future a bit? What's coming down the pipeline? Do you have any ideas of what we might want to change next?
Yes. So one of the things we did as part of this feature set is make one of the operations faster. So remember, they wanted to bulk delete things. So there's an existing operation called purge partition, which is optimized to delete objects in in a partition, quickly avoiding some of the overheads. A big one that it avoids is that journaling overhead. So when you delete partition, we don't journal anything. So that big pain of terabytes of journals gone. So that's there anyway. So you can do that. But what we kept up our sleeves is do it even faster than that, because per partition does have to do some work, and the main thing it does is maintains referential integrity. So there's a bit of a cost in there with some performance changes to make that faster. We've made it roughly 4 times faster, but we can make it faster still. So, and we worked out how to do that. But we've kept that up our sleeves. We'll wait on feedback from the customer to see if they need it.
Nice.
And yeah, always room for improvement.
Cool. Well, thanks for that, Hugh. I learned a lot, and hopefully the audience did all as well. And until next time, we'll catch you in the next whiteboard session.
Thanks, Tim.